Hello children, welcome back to the digital classes. I hope you are all doing well and you might all be excited to learn some new concepts in this session. So, we will start with our session without wasting much time. Now, take a look at the images shown on your screen children. The first one, if you consider, it is a trapezium, whereas the second one is a parallelogram, third one is a kite, fourth one a rectangle, fifth a rhombus, and the last one is a square. We have already learnt some theorems in our first session of quadrilaterals. The theorem states the diagonal of a parallelogram divides it into two congruent triangles. Not only that, we have learned few more theorems also, like in a parallelogram opposite sides are equal and opposite angles are also equal. But children, have you heard about a corollary? Yes. Let us see what a corollary is, children. The statements that are deduced from previously known and proved statements are called corollary. That means, we are going to prove these statements using the theorem which we have already proved. So, those statements are said to be corollary. So, children, today in our session, that is quadrilaterals part 2, we are going to learn about all these things, children. So, by the end of this session, you will learn more geometrical statements, midpoint theorem, and also the converse of midpoint theorem. So, children, I already told you about corollary, isn't it? So, those are also statements which we are going to prove it by using already proven statements that we have already learned in our first session. Okay, children. So, let us start with our first corollary. Show that each angle of a rectangle is a right angle. So, this is our first corollary. What are we going to do now? Yes, we have to prove this. For that, I have taken a rectangle ABCD. So, here ABCD is a rectangle and I will assume one of the angle as 90 degrees. So, let us consider angle A is 90. So, what we need to show, children? Yes, I have to prove again angle B, angle C and angle D, all these are equal to 90 degrees each. Okay, got it, children? Now, let us prove them. And we know that a rectangle is a parallelogram, isn't it, children? Because we have already seen the definition of a rectangle. So, a parallelogram in which opposite sides are parallel, right? So, in a rectangle also, if you see, both the pairs of opposite sides are parallel. So, I can say a rectangle is a parallelogram. So, here ABCD rectangle is nothing but a parallelogram ABCD. Now, in this parallelogram ABCD, we know that the opposite pairs of sides are parallel to each other. That means, I can say AB parallel to CD and AD is what? The transversal. So, here you can notice this AD has become the transversal. These two lines are parallel, these two sides are parallel actually, and this AD has become the transversal. Now, in this transversal, I can write angle A plus angle D is 180 degrees. That means, this angle plus this angle. The sum of these two is 180. But why the sum of these two angles is 180, children? The interior angles on the same side of the transversal are supplementary. So, that is the reason we have A plus D is 180 degrees. But we have already assumed A as 90 degrees, children. So, we are substituting A is 90 plus angle D is 180. Now, what is the value of D, children? Yes, it is 180 minus 90. So, how much you get, children? You are right, that is 90 degrees. So, we got angle D as 90 degrees. But already angle B and D are equal and angle C and D are equal. Now, why these two are equal, children? B and D and C and A? That means, if you see, this is B and this is D, whereas this is A and this is C. These pairs of angles are equal. The reason is, yes, ABCD is a parallelogram. So, in parallelogram, we have seen that opposite angles are always equal. So, that is the reason we have angle B and D are equal and angle C and A are also equal. Now, let us substitute these values, children. So, B is also equal to 90 degrees. Why B is 90 degrees? Because D is 90. So, B and D are equal. So, B is also 90. Then what about C, children? Yes, C is also 90. Why C is 90? Because A is 90. So, now we got A is equal to 90, B is equal to 90 degrees, C is equal to 90 degrees and also D equal to 90 degrees. That means, I can say that each and every angle of a rectangle is a right angle. So, this is about our first corollary, children. So, let us move on to our next corollary. Show that the diagonals of a rhombus are perpendicular to each other. Let us see the proof, children. So, let us consider a rhombus. So, a rhombus is nothing but a parallelogram with all the sides as equal. That we have already learnt in the definition, children, isn't it? So, we are going to take a rhombus ABCD. Now, in this rhombus ABCD, you can notice all these four sides, that is AB, BC, CD and DA are equal. Now, in this, let us draw two diagonals, that is AC and BD. Both are intersecting at point O. Now, children, here what actually we need to prove? The diagonals are perpendicular to each other. What are the diagonals here? AC and DB. So, we just need to prove AC perpendicular to BD. That means, the angle between these two diagonals is 90 degrees. That is what we need to show, children. Now, let us see how to prove that, children. So, I will consider triangles AOB and BOC. So, here you can notice this is our AOB, and next we will consider our another triangle, that is BOC. You can notice these two triangles. Now, in these two triangles, what do you notice, children? Yes, we see that AB and BC both are equal, because all sides are equal in a rhombus. So, AB and BC are equal. Then, why? The reason is sides of a rhombus. Then, OB is the common side. So, in these two triangles, this is the common side OB. So, that is also equal. So, write it as common side. Then next, if we consider AO and OC, that means AO and OC, these two parts are also equal. But why these two parts are equal, children? Yes, the diagonals of a parallelogram bisect each other. So, your rhombus is nothing but a parallelogram, right? So, the diagonal bisect each other, that means this O divides AC into two equal parts. So, OA and OC both are equal. If you notice these two triangles, that is triangle AOB and BOC, these two triangles are congruent. But why? What is the reason? If you notice these two sides, am I right? And this is the common side. That means three sides of triangle AOB and three sides of triangle BOC both are equal. So, I can say by SSS congruency, both the triangles are congruent. So, by CPCT, that means corresponding parts of congruent triangles, I can write angle AOB and angle BOC both are equal. So, if you notice angle AOB, that is this part, and angle BOC, that means this angle, both are equal. Okay, children. Now, let us add these two angles, that is AOB and BOC. So, why these two is equal to 180 degrees, sum of these two? Yes, the reason is they are linear pair. So, AC forms a straight line. So, we have taken a point on straight line. Now, this total angle will be 180 degrees. So, that is why AOB plus BOC is 180. But children, if you notice, we have seen AOB and BOC both are same. So, in place of BOC, I am writing AOB. So, 2 times AOB is 180 degrees, angle AOB is equal to 90 degrees. So, we got one of the angle as 90 degrees, but already we have seen AOB and BOC are same. So, even BOC is also equal to 90. So, similarly, you can prove COD as 90 degrees and even DOA as 90 degrees. That means, I can say that AC is perpendicular to BD because they are intersecting at right angles. So, now we have proved that the diagonals of a rhombus are perpendicular to each other. So, children, we have seen two of the corollaries and we have proved also the statements given in those corollaries. Now, let us move on to our next corollary. So, in a parallelogram ABCD, if the diagonal AC bisects angle A, then ABCD is a rhombus. Let us prove this statement, children. So, let us consider the parallelogram ABCD, and what is given, children? Yes, AC is bisecting the angle A. So, here you can see AC, this is the diagonal. Okay. So, this diagonal is bisecting this angle A, that means these two angles are equal. Okay, children. Now, since it is a parallelogram, I can write AB parallel to DC. So, if you notice these two opposite sides both are parallel to each other, and also it intersects both the angles. You can notice A and C. This diagonal is intersecting angle A and also intersecting angle C. Got it? Then we can write angle BAC and angle DCA both are equal. So, you can see, children, these two parts are equal. Not only that, if you notice the other two parts, that is angle BCA, this part. So, this part you can see shaded in white, and also DAC, this part, they are also equal. The reason is they are alternate interior angles. So, we have seen that whenever two parallel lines are there and a transversal intersects the parallel lines, their alternate interior angles are equal. So, here these two are two pairs of alternate interior angles, and also given AC bisects angle A. So, you can see the diagonal AC is bisecting angle A, which means I can write angle BAC and angle DAC, both are equal. These two angles are equal because it is bisecting. Bisecting means dividing it into two equal parts. So, these are the two equal parts, that is DAC is one equal part and BAC is another equal part. So, these two must be equal. Therefore, I can say angle BCA and angle DAC are equal. Now, let us see why these two are equal, children. So, we got these two parts are equal, right, but why they are equal? See, these two are equal, okay, and these two are equal, and apart from that again we got these two are also equal. Hence, I can say these two angles are also equal. So, if you notice from these two I can write even DCA and DAC are also equal. So, that is the reason, children. So, hence I can say that AC bisects angle C. So, these two are also equal. So, since these two are equal, this AC will become bisector because it is also dividing it into two equal parts. Angle C is divided into two equal parts. Okay, children. Now, let us consider the triangles ABC. Okay. Now, in this triangle ABC, you can notice these two angles are equal, that is angle BAC, this part, and angle BCA. So, BCA, this part. In a triangle, whenever two angles are equal, the sides opposite to them are also equal. Now, which are the two sides opposite to them? Yes, BC and AB. So, these two are equal to this is the opposite side, to this angle, this is the opposite side. So, that means AB and BC both are equal. So, this is the reason we have AB equal to BC. Already it is known that AB and DC both are equal because opposite sides of a parallelogram. BC equal to AD means opposite sides of a parallelogram. Now, from these two equations, I can say AB equal to BC equal to CD and equal to AD. That means all these four sides are equal. Now, since all four sides are equal, then it forms a rhombus. That means we have proved ABCD is a rhombus. Let us move on to our next corollary. Show that the diagonals of a rectangle are of equal length. So, let us see the proof, children. So, let us consider a rectangle ABCD in which AC and BD are diagonals. And here what we have to show, the length of diagonals are equal. That means AC and BD both are equal. Now, for that what we need to do, just we will consider triangle ABC and also BAD. So, in these two triangles, AB is the common side. So, that means if you notice ABC, so in this ABC we have side AB, again in this BAD, this triangle, we have again AB also. So, in both the triangles AB is the common side. So, AB equal to AB, that is common side, and I can write BC equal to AD also. Why these two are equal? Because in a rectangle the opposite sides are equal. So, that is why BC equal to AD. Then anything else, children? Yes, angle A and angle B both are equal and equal to 90 degrees. Again, why these two angles are equal to 90 degrees? Because again it is an rectangle. In a rectangle, each and every angle is 90 degrees. So, by SAS congruency, I can write triangle ABC and triangle BAD are congruent. So, by CPCT, now what is meant by CPCT, children? Yes, corresponding parts of congruent triangles. Now, in these two triangles are congruent. What are the congruent parts left now? AC and DB. So, these are the corresponding parts. So, corresponding parts of congruent triangles are equal. So, I can say AC equal to BD. AC is one diagonal and BD is another diagonal. Hence, they have same length. Therefore, the diagonals of a rectangle are of equal length. Let us move on to our last corollary, children. So, show that the angle bisector of a parallelogram form a rectangle. So, let us prove the, children. Let us consider a parallelogram ABCD. Now, let us draw the bisectors of these angles, all the four angles. Let us see how to draw the bisectors. So, for angle A, for angle B, angle C and angle D, and mark these points as P, Q, R and S. So, PQRS is a, yes, it is a quadrilateral because it is a simple closed figure with 4 sides. Now, this quadrilateral which is formed is a rectangle. That is what we are going to prove, children. So, let us consider AB parallel to DC, because ABCD is a parallelogram, opposite sides are parallel. Then again I will consider angle ABC. So, this part plus angle BAD. So, this part, sum of these two is 180 degrees. Why, children? Because interior angles on the same side of the transversal are supplementary. So, now I will consider angle BAP. Now, where is BAP, children, here? If you consider, this is BAP. So, this angle is equal to half of BAD. Why half of BAD? Because A is this line, that is AP, I can say it is a bisector of angle A, and also angle ABP, angle ABP. So, this part, okay. So, this part is half of this total part, because again BP is also a bisector. So, angle ABC plus angle BAD is 180 degrees. Now, can I write half of ABC plus half of BAD is half into 180? I am multiplying by half in both LHS and RHS. ABP plus BAP is equal to half of 180 is 90 degrees. Now, let us consider triangle APB, this triangle, bigger one. In this, we have noticed these two angles now, which is shaded here, sum of these two is 90. So, in a triangle we know that sum of 3 angles is 90. Out of this, sum of these two is 90. So, this remaining angle here, this part should be equal to 90. So, this is nothing but APB. So, we have now APB as 90 degrees. So, since APB is 90 degrees, can I write that is nothing but SPQ. So, SPQ is same this part only, and even ABP is also this part only. So, I can write both are same, which is 90 degrees. Similarly, I can prove PQR is equal to 90 and also QRS as 90 and PSR is also 90 degrees. That means, all the 4 angles are equal and they are equal to 90 degrees each. Got it, children? So, since all angles are equal, I can say it is a rectangle because they are all equal to 90 degrees. Children, till now we have proved some corollaries. Now, let us move on to our next part, that is midpoint theorem. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it. So, this is the statement of our first theorem. So, we have a triangle ABC and a line segment is there which is joining the two midpoints. What are the midpoints here? D and E. Now, what is needed to prove? Yes, let us measure this DE. So, this is 2.7 centimeters. Let us measure even BC also. So, if we measure using a scale, it is 5.4. So, what do you notice, children? Yes, BC is 2 times of DE, or in other words I can say BE is half BC. Got it, children? So, apart from this, if we measure angle ADE and angle B, both are equal. That means, a pair of corresponding angles are equal. That means, the lines are parallel, which means I can say DE is parallel to BC. So, this is our theorem. So, children, we have seen what is a midpoint theorem. Now, let us prove it. So, mark the midpoints E and F of triangle ABC, and E is midpoint of AB and F is midpoint of AC. Now, what is required to prove, children? Yes, the first one is EF parallel to BC and the second part is EF is half of BC. Okay, children. So, you can notice EF is parallel to BC and EF is half of BC. Now, let us start with the proof, children. So, for that we are going to extend EF to D and join CD, so that CD is parallel to BA. So, now let us consider triangles AEF and CDF. So, you can see these two triangles. In this triangle, if you notice, AF is equal to FC. But why these AF and FC are equal, children? Because F is midpoint of AC, that is why AF and FC are equal. And if you notice, angle AFE and angle CFD are equal because vertically opposite angles. At the same time, if you notice, angle AEF and angle CDF are equal. Why they are equal? because they form alternate interior angles. So, in these two triangles I can say two angles and one side of one triangle are respectively equal to two angles and one side of another triangle. So, I can write these two triangles are congruent, that is triangle AEF and CDF are congruent. What is the reason? You are right, by ASA congruency. So, by CPCT again I can write AE and CD both are equal. So, these two parts, if you notice children, AE and CD both are equal. Apart from that, what can you write? Yes, EF is also equal to FD or DF. So, EF and FD or DF both are same, but already it is given that AE equal to BE. So, AE and BE both are equal because E is midpoint of AB. So, now from these two, that is AE equal to CD and A equal to BE, I can write yes, BE is equal to CD. That means you got BE, that is this part, and this part CD both are equal. Therefore, I can say this BCDE, it is actually a quadrilateral, right. Now, in this quadrilateral, one pair of opposite sides are equal and parallel. Therefore, it is a parallelogram. Now, since it is a parallelogram, I can write ED is parallel to BC, because in a parallelogram both the pairs of opposite sides are parallel. Got it, children? So, I am considering ED parallel to BC. Now, since ED is parallel, now EF is also parallel to BC, because EF is a part of ED. So, EF is parallel to BC. So, we got the first part, EF parallel to BC. Now, we have to prove the second part, that is EF is half of BC. So, for that we will consider ED equal to BC. So, where is ED, children? This one ED and BC. Now, why these two are equal? Because they are opposite sides of a parallelogram. Now, I can write ED as, so this total distance, ED is nothing but this total distance. Now, this total distance equal to this distance EF plus FD. So, that is equal to BC. Just now we have seen EF and FD both are equal. That means, in place of this FD, I can write EF. So, 2EF is BC. Therefore, EF is half of BC. So, this theorem we call it as the midpoint theorem. Got it, children? So, children, you have understood what is actually a midpoint theorem and its proof also. Now, let us move on to the converse of midpoint theorem. The line drawn to the midpoint of one of the sides of a triangle and parallel to another side will bisect the third side. So, what is given, children? A triangle. Okay. Now, this triangle ABC, E is midpoint of AB. Now, through this E, draw a line L. Now, that line L is parallel to BC and it is intersecting at F also. Now, what is that we need to prove? Yes, we have to prove that this line bisects the third side, that is, this is the line, okay, that is line L, this is the line L and this is the third side. It has to bisect the third side, that means it is going to divide AC into two equal parts at this point F, that means AF must be equal to FC. So, that is what we need to prove, children. Now, for that, let us move on to a small construction. So, let us draw CD parallel to BA and let it intersect at D. Okay, children. So, we are marking a point D on L and joining CD so that this CD is parallel to BA, this total thing. Now, what can you write, children, this BCDE? Yes, it is a parallelogram, because already we have this line L, means ED is parallel to BC and BE parallel to CD. So, both the pairs of opposite sides are parallel. So, it is a parallelogram. Now, since it is a parallelogram, I can say that the opposite sides are equal, that is BE equal to DC, A equal to BE, because it is given already E is midpoint, it is exactly dividing it into two equal parts. So, that is why AE and BE both are equal here. Then, basing on these two conditions, I can write again AE and DC both are equal, that is AE, so this part, and also CD, this part, both are equal. Now, let us consider the triangles AFD and CDF. So, in these two triangles, I can write angle EAF and angle DCF, both are equal. Not only that, angle AEF and angle CDF, these two are also equal, because they are alternate angles. Now, if you notice these two triangles, okay, two angles and included side of one triangle are equal to two angles and included side of another triangle. Therefore, these two triangles are congruent by angle side angle, that is A is a congruency rule. Now, since they are congruent by CPCT, I can write this AF and FC both are equal. So, this AF and FC both are equal. Hence, I can say that this line L is bisecting the side AC. So, this theorem is known as the converse of midpoint theorem. So, children, we have seen some corollaries. Apart from that, we have proved the midpoint theorem and also its converse. Now, let us apply these concepts what we have learned in solving few problems. Let us start with our first problem, children. L, M and N are three parallel lines intersected by the transversals P and Q at A, B, C and D, E, F, such that they make equal intercepts AB and BC on transversal P. Show that the intercepts DE and EF on Q are also equal. Let us start with the solution. So, what is given, children? Three parallel lines L, M and N. And what else is given? Yes, there are two transversals P and Q. Now, transversal P is intersecting lines L, M, N at A, B and C. What about transversal Q? It is intersecting at D, E and F. So, here these two are intersecting. Got it, children? So, I can, and also it is given AB equal to BC. Now, let us join AF. Now, this AF is intersecting line M at G. So, in triangle ACF, B is midpoint of AC, BG parallel to CF. You can notice by converse of midpoint theorem, I can say that G is also midpoint of AF. Got it, children? Now, let us consider triangle ADF. G is midpoint and G is parallel to AD. Again, by converse of midpoint theorem, E also becomes the midpoint of DF. So, DE is equal to DF because E is midpoint. So, DE must be equal to EF. So, from this what we can conclude? Yes, L, M and N cuts off equal intercepts on Q also. So, children, before we end our session, let us quickly recap what we have learnt in this session. Each angle of a rectangle is a right angle. The diagonals of a rhombus are perpendicular to each other. The diagonals of a rectangle are of equal length. The angle bisector of a parallelogram forms a rectangle. Midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is always parallel to the third side and also half of it. And converse of midpoint theorem states the line drawn to the midpoint of one of the sides of a triangle and parallel to another side will bisect the third side. So, children, let us work out some problems based on the concept that we have learnt in this session and submit these problems to your teacher. So, children, with this we come to the end of our session. I hope you have learnt all the concepts clearly and understood the proofs of the theorems also. And please do work out the problems and show it to your teacher. So, we will meet in our next digital class. Until then, goodbye and take care.